December 2, 1943, or for 27 hours, Rabaul Harbor, New Britain. The sky is still black, stitched only by searchlight beams clawing upward through tropical humidity. On the deck of the Japanese heavy cruiser Agano, sailors scramble to battle stations. As air raid sirens wail across the anchorage, radar operators in the Harbor Defense Center squint at cathode screens, tracking what they believe is a standard American bomber formation inbound from Bougainville. Predictable, vulnerable. Anti-aircraft batteries swivel toward the southeast. Gunners load shells. Officers shout grid coordinates. This is routine. The Americans always come at dawn. They always lose planes. They always fail to land decisive hits. But this morning, something is different. The formation splits. One element climbs. The others drop to wave-top altitude, engines screaming at full throttle, closing distance at impossible speed. By the time the first gun crews register the mistake, Torpedo wakes, are already streaking white across black water. Agano takes 2 hits amidships. A destroyer Naganami explodes in a pillar of flame. Another cruiser lists violently as seawater floods engine rooms. In less than 4 minutes, the anchorage is a hellscape of burning oil and sinking steel. The Americans vanish into the darkness before a single fighter can scramble. Japanese after-action reports filed later that day speak not of enemy strength, but of disbelief. The attacking aircraft demonstrated coordinated precision inconsistent. With known U.S. torpedo bomber capabilities, speed and maneuverability exceeded established profiles. Losses to defensive fire, 0. Imperial Japanese Navy Operations Log, December 1943. What the defenders at Rabaul could not comprehend what Axis intelligence analysts across the Pacific would spend the next 18 months struggling to explain was that they had just encountered the deadliest American aircraft of the Pacific War, not the celebrated B-17, not the rugged Corsair, not even the Hellcat that would dominate the Marianas Turkey shoot, the plane that tore through Rabaul that morning. Racking up kill ratios so lopsided they bordered on statistical anomaly. Was an aircraft dismissed by its own Navy as overcomplicated, overweight, and operationally impractical? The Grumman TBF Avenger. By late 1943, the Pacific theater had become a grinding war of attrition across 6,000 miles of ocean. The United States fielded 14 fleet carriers, 83 escort carriers, and over 2,000 frontline aircraft. Japan, bloodied at Midway and Guadalcanal, retained 6 operational fleet carriers and fewer than 1,500 naval aircraft, many piloted by hastily trained replacements. U.S. Strategic Bombing Survey, 1946. American doctrines centered on carrier task force superiority, fighters for air control, dive bombers for precision strikes, torpedo bombers for ship killing. In theory, the last Roller-Latcher torpedo attack was the most dangerous and least effective mission in naval aviation. Torpedo bombers flew slow, straight, and low. They were magnets for flak and zeros. At the Battle of Midway, Torpedo Squadron 8 lost all 15 aircraft without scoring a single hit. Across 1942, U.S. torpedo bomber losses exceeded 60% per major engagement, with hit rates hovering below 10%. U.S. Navy Air Combat Intelligence Reports, 1942-43. The weapon itself, the Mark 13 torpedo, was a disaster, prone to running deep, detonating prematurely, or failing to detonate at all. Pilots joked bitterly that the most dangerous thing about a torpedo run was carrying the torpedo dot, and yet by mid-1944, one aircraft type up operating with the same flawed torpedoes, the same hostile skies, the same doctrine was achieving kill ratios of 12-1. Avenger squadrons were sinking cruisers, destroyers, transports, and submarines with surgical consistency, while sustaining losses below 4% per sortie. Bureau of Aeronautics Operational Summary, 1944. Japanese commanders began referring to unidentified low-altitude attackers simply as the fat ones, a grudging acknowledgement that something had shifted. Allied intelligence officers combing through captured documents found repeated references to American torpedo bombers exhibiting abnormal survivability and unanticipated tactical flexibility. ATIS. Translation No. 2nd. January 1944. Axis fighter pilots reported engaging what they assumed were lumbering targets. only to find themselves outmaneuvered at altitudes where a torpedo bomber should not be capable of violent evasive action. Anti-aircraft gunners trained to track slow-moving aircraft suddenly faced targets, jinking, diving, and accelerating through flak barrages with a speed and agility that defied the known performance envelope of any torpedo bomber in service. The TBF Avenger did not look like a miracle weapon. It looked like a flying bathtub. Designed by Grumman Aircraft Engineering Corporation under lead engineer Robert Hall and chief engineer William Schwendler, the Avenger was conceived in 1940 as a replacement for the obsolete Douglas TBD Devastator. Hall's design philosophy was unorthodox. Instead of minimizing weight and complexity to maximize speed, the dominant trend in aviation design, he packed the Avenger with systems: redundant hydraulics, self-sealing fuel tanks, a powered turret, armor plating around the crew compartment, a ventral gun position, a bomb bay large enough to carry not just torpedoes, but bombs, depth charges, or rockets. The aircraft weighed over 10,000 pounds, empty, nearly 16,000 pounds loaded, more than many contemporary medium bombers' technical manual, an 0185 F1, 1943. Navy procurement officers called it overengineered. Test pilots called it a truck. The first prototype crashed on its maiden flight, killing the pilot. Critics within the Bureau of Aeronautics argued for cancellation, but Hall and Schwendler refused to simplify. They believed survivability mattered more than elegance. They believed a crew that came home could fly again. They believed complexity, properly integrated, became an advantage. The Avenger entered service in June 1942, just in time for Midway, where 6 of the first 12 Avengers deployed were shot down. U.S. Navy Action Report, June 4, 1942. Early results seemed to confirm every criticism. The plane was too heavy, too slow, too visible. But then something unexpected began to happen. As crews gained experience, as doctrine evolved, as small modifications accumulated in maintenance logs and field reports, the Avenger's lethality began to climb. By late 1943, operational squadrons were reporting mission success rates above 70%. By mid, Avengers had sunk more Japanese tonnage than any other U.S. aircraft type, including the vaunted SBD Dauntless dive bomber. U.S. Navy Aviation Statistics, 1945. Crews who survived their first 5 missions often completed 30 or more. Loss rates dropped, kill counts soared. And across the Pacific, in encrypted Japanese naval communications, a single question began appearing with increasing urgency. What are the Americans doing differently? The answer lay not in what the Avenger carried beneath its wings, but in what it carried inside its fuselage. Woven into its electrical harnesses and hydraulic lines, hidden within layers of design decisions that Navy skeptics had once dismissed as overcomplication. The secret was not a weapon. It was a philosophy translated into steel, wire, and oil that would rewrite the rules of naval aviation and leave the enemy grasping its shadows over burning harbors. Because the deadliest thing about the Avenger was not its torpedo, it was everything else. The revelation came not in a single blinding moment, but in 1,000 small realizations accumulated across maintenance hangars, ready rooms, and debriefing tents from Tarawa to the Philippines. What made the Avenger lethal was not revolutionary technology or exotic materials, it was systemic design integration so thorough that the aircraft behaved less like a collection of components and more like a single, adaptive organism. While Japanese torpedo bombers like the Nakajima B-5N Kate prioritized speed and payload through weight reduction, sacrificing crew protection and redundancy, the Avenger embodied the opposite calculus: survive first, strike second, return always. Robert Hall and his engineering team at Grumman's Bethpage, Long Island facility had built an aircraft that refused to die, and in naval aviation, survivability translated directly into cumulative lethality. Grumman Engineering Report, G14, April 1941. The first and most visible advantage was structural. The Avenger's fuselage incorporated over 400 pounds of armor plating surrounding the crew compartment, engine, and oil cooler weight that contemporary designers would have rejected as prohibitive. But this armor was not merely bolted-on protection. It was load-bearing structure, integrated into the airframes, stress distribution, self-sealing fuel tanks, developed by United States Rubber Company engineers using vulcanized layers that swelled when punctured, lined the wings and fuselage. When 20 mm cannon shells, or 7.7 mm machine gun rounds, tore through the Avenger's skin, and they did, constantly, the aircraft bled fuel slowly rather than erupting into fireballs. Pilots returning from missions over Truck Lagoon reported landing with wings resembling Swiss cheese, fuel gauges reading near, and crew uninjured. VT-16 Squadron War Diary, February 1944. Japanese pilots, trained to expect catastrophic results from burst hits on fuel tanks, found themselves expending ammunition into targets that simply refused to explode. One captured Zero pilot, interrogated at Guadalcanal in late 1943, described firing a full ammunition load into an Avenger at close range, observing strikes along the fuselage and wings, and watching in frustration as the bomber continued straight and level toward its target, before escaping into cloud-covered dramatized composite based on ATIS interrogation summaries. 1943-44, but armor and fuel tanks were passive defenses. The Avenger's active survivability systems, hydraulics, controls, electrical were where Grumman's philosophy became radical. The aircraft featured dual independent hydraulic systems, one primary, one backup, routed through separate channels along opposite sides of the fuselage. If flak severed the primary system, the backup automatically engaged, maintaining control surface authority. The electrical system likewise ran redundant buses. Flight controls used a combination of cable and pushrod linkages, designed with enough mechanical advantage that even with partial hydraulic failure, a pilot could muscle the aircraft home. Technical Manual and 0185F1, Section 4. Maintenance crews at NAS Alameda reported aircraft returning with hydraulic lines shredded, electrical harnesses burned, and still retaining sufficient control for carrier landings. NAS Alameda Maintenance Log, July 1944. This redundancy was not accidental. Schwendler's design team had studied every devastator loss at Midway, cataloging failure points, and engineered solutions into the Avenger's architecture, where the TBD had single-point vulnerabilities: one hydraulic line, one control cable path, one fuel tank. The TBF had backups. Complexity became resilience. The second hidden advantage was tactical flexibility, born from the Avenger's capacious internal bomb bay and weapons stations. The bay measured 63 inches long, large enough to accommodate not just the standard Mark 13 torpedo, but for 500-pound bombs, 8 250-pound bombs, depth charges, or 16 5-inch high-velocity aircraft rockets, HVAR, on underwing racks. This modularity allowed squadron commanders to configure the same airframe for ship attack, ground support, anti-submarine patrol, or mine laying, often within hours of mission briefing. At the Battle of the Philippine Sea in June 1944, Avenger squadrons from Task Force 58 launched configured with mixed loads. Some carried torpedoes for the Japanese carrier fleet, others hauled bombs for airfield suppression on Guam, still others flew anti-submarine screens with depth charges. Action Report, TF-58, June 1944. Japanese defenders, expecting homogeneous American strike packages, instead faced heterogeneous threats that overwhelmed tactical responses. Fighter directors could not predict whether inbound Avengers would attack ships, airfields, or submarines. Anti-aircraft batteries optimized for high-altitude bombers found themselves engaging low-altitude torpedo spreads. The Avenger's versatility created operational ambiguity, and ambiguity bred paralysis. The third advantage, least visible but most decisive, was crew survivability architecture. The Avenger seated 3, pilot, turret, gunner, and radioman bombardier. Unlike single-seat fighters, where pilot incapacitation meant certain loss, the Avenger's crew could compensate. The radioman occupied a ventral position with a .30 caliber machine gun covering the belly. The turret gunner operated a powered Grumman-designed turret, mounting a .50 caliber machine gun with 400 rounds and a 360-degree traverse capability. This turret, electrically powered, hydraulically stabilized, was unprecedented in American torpedo bombers. The earlier TBD had a manually operated .30 caliber gun on a flexible mount. The turret gunner could barely traverse fast enough to track attacking fighters. The Avenger's turret, by contrast, could slew rapidly, track targets through violent evasive maneuvers, and deliver sustained suppressive fire. More critically, the turret and ventral gun created overlapping fields of fire that forced attacking fighters to approach from narrow angles where the pilot's forward-firing .50 caliber guns could engage. Grumman Design Analysis. Turret Installation. December 1940. Japanese fighter tactics, honed against defenseless torpedo bombers. Suddenly faced aircraft that shot back effectively from multiple angles. Combat loss data confirmed the impact. Avengers, under simultaneous attack by multiple fighters, sustained lower loss rates than solitary aircraft, because coordinated defensive fire from a three-plane section created interlocking fire zones. Fighter Direction Analysis. 1944. November 5, 1943. Rabaul Harbor. Second strike. This time the Japanese are ready, or believe they are. 40 Mitsubishi A6M0s patrol overhead. Shore batteries are fully manned. Smoke generators obscure the anchorage. At 13:20 hours, radar detects inbound strike. 16 Avengers from VT-9 and VT-17, escorted by the Zeros dive to intercept, confident they have numerical superiority, they have altitude, they have veteran pilots. What they do not have is doctrine adapted to the Avengers' capabilities. The Americans descend in coordinated elements, 4-plane divisions, each division staggered vertically and laterally, maintaining mutual support. Zeros attack from astern, the classic high sight. Stern approach perfected over China and immediately encounter massed .50 caliber fire from powered turrets, tracking smoothly through the defenders. Approach curves. 2 Zeros break off trailing smoke. The rest press attacks, raking Avenger fuselages with 20mm cannon fire. Rounds punch through aluminum skin. Fuel tanks weep. Hydraulic fluid mists, and the bombers continue. Throttles firewall, descending through a curtain of anti-aircraft bursts, toward dropping altitude. At 200 feet, still 3 miles from release point, the formations split. Some Avengers break toward the northern anchorage, others toward the southern basin. Defensive fire disperses, tracking multiple threats. At 150 feet, the Avengers level. Bomb bay doors yawn. Torpedoes drop, strike water, run hot, and true fire. After months of modifications, the Mark 13 works reliably thanks to drag rings and wooden nose shrouds developed by engineers at the Naval Torpedo Station in Newport, Rhode Island. Bureau of Ordnance Report. Torpedo Mk-13 modifications. October 1943. Destroyers Suzutsuki and Umikaze take hits. A transport erupts. Oil tanks ashore detonate. The Avengers pull up through curtains of shrapnel. Turrets still firing, and claw for altitude. 14 return to base. 2 are damaged but repairable. 0 losses. Japanese records note simply, enemy aircraft demonstrated unacceptable resistance to defensive fire. Tactics require revision. IJN 11th Air Fleet Combat Summary. November 1943. But tactics could not be revised fast enough. The fundamental problem was industrial. Grumman's Bethpage plant, supplemented by General Motors' Eastern Aircraft Division factories in Trenton and Baltimore, produced Avengers at staggering scale. 9,836 aircraft between 1942 and 1945, peaking at over 400 per month in mid-1944. Grumman production records. 1945. This output dwarfed Japan's entire torpedo bomber production. More aircraft meant more sorties. More sorties meant more crew experience. More experience meant higher mission success rates and lower losses, a virtuous cycle. By contrast, Japanese naval aviation, shattered at the Philippine Sea, could not replace losses. Experienced pilots died. Replacements flew poorly. Aircraft trickled from factories. The Avengers industrial base became a strategic weapon. Every mission flown accumulated organizational knowledge, refined tactics, and compounded enemy attrition. American squadrons in early 1945 included pilots with 40, 50, even 60 combat missions men who understood their aircraft's capabilities intuitively, who had survived situations that killed novices, who mentored replacements and transferred. By January 1945, the strategic calculus of the Pacific War had shifted irrevocably. The Avenger, once derided as an overweight compromise, had become the primary instrument of Imperial Japanese Navy destruction. Across 27 months of sustained operations from the Solomons to the home islands, Avenger squadrons accounted for the sinking or crippling of 4 fleet carriers, 11 escort carriers, 19 cruisers, 43 destroyers, and over 300 transport and auxiliary vessels, more tonnage than all other U.S. Navy aircraft types combined. U.S. Strategic Bombing Survey, Naval Analysis Division, 1946. The cumulative effect was not merely material, but psychological. Japanese naval commanders, already reeling from catastrophic carrier losses at Philippine Sea and Leyte Gulf, faced an opponent whose torpedo bombers no longer represented acceptable trade-offs, but near certainty of mission success and survival. Doctrine crumbled. Defensive tactics ossified into fatalism. The aircraft designed to survive had, through sheer persistence, exhausted the enemy's capacity to resist. The strategic impact manifested first in operational tempo. Traditional naval aviation doctrine assumed significant aircraft attrition. Pre-war planners calculated that carrier air groups would lose 30 to 40% of their strength per major engagement, requiring weeks of reconstitution. U.S. Navy Warplans Division, 1940. The Avenger invalidated this assumption. Squadrons operating from escort carriers in the Philippines. Campaign flew sustained daily sorties for 60 consecutive days without falling below operational strength. Maintenance crews repairing battle damage overnight, while fresh aircraft cycled into the rotation. CVE-73 USS Gambier Bay Air Group Log, October-November 1944. This relentless pressure prevented Japanese forces from regrouping, rearming, or repositioning. Supply convoys attempting to reinforce garrisons at Truk, Rabaul, or Formosa found themselves hunted around the clock by Avenger patrols. Losses mounting until entire logistics networks collapsed. By mid-1944, Japanese army units on bypassed islands were effectively besieged, not by ground forces, but by carrier-based interdiction that made resupply suicidal. The Avenger's survivability enabled a operational persistence that translated into strategic paralysis. The enemy could not move, could not reinforce, could not withdraw without accepting catastrophic losses. The psychological dimension deepened with each engagement. Captured Japanese naval personnel, interrogated by Allied intelligence teams in the months following Leyte Gulf, repeatedly described a pervasive demoralization centered specifically on American torpedo bombers. One destroyer captain, whose ship had survived Avenger attacks at both Philippine Sea and off Formosa, before finally succumbing near Okinawa, stated through interrogators, "We trained to defeat torpedo bombers through aggressive maneuvering and concentrated fire. But the American aircraft absorbed damage that should have been fatal, coordinated attacks from directions our doctrine did not anticipate, and returned in numbers we could not deplete. After Philippine Sea, we understood we were fighting an enemy whose industrial capacity exceeded our ability to inflict meaningful attrition." Dramatized composite based on U.S. Naval Technical Mission to Japan interrogation. Reports, 1945-46. This was not mere tactical frustration, but strategic despair. The recognition that the fundamental assumptions underlying Japanese naval aviation had been rendered obsolete by an opponent who refused to accept losses as inevitable. The human infrastructure sustaining the Avengers' dominance extended far beyond cockpits. At forward bases throughout the Pacific, maintenance crews worked in conditions ranging from primitive to hellish. Coral dust clogging hydraulic systems, salt air corroding electrical connections, tropical heat warping aluminum skin panels. Yet serviceability rates for deployed Avenger squadrons consistently exceeded 75% higher than fighters, higher than dive bombers, higher than any multi-engine type Commander Air Force Pacific Logistics Assessment, June 1944. This reliability was engineered. Grumman's design incorporated modular components. Engines could be swapped in 4 hours, turrets in 2, hydraulic systems in 6. Maintenance manuals written by engineers who had built the aircraft provided step-by-step troubleshooting procedures with illustrated diagrams. Spare parts, manufactured to exacting tolerances at Eastern aircraft plants and shipped via Liberty ships, arrived in theater with predictable regularity. The Avenger's complexity, rather than becoming a logistics nightmare, revealed itself as maintainability at scale, proof that sophisticated systems, properly supported, could sustain high operational tempos in austere environments. The men who kept Avengers flying: aviation machinists, mates, electricians, mates, ordnancemen working 16-hour shifts in quants at huts and open-air revetments, revetted the invisible half of the kill ratio equation. Every aircraft that launched, struck, and recovered represented not just pilot skill, but the labor of dozens who ensured hydraulic pressure held, electrical systems functioned, and control surfaces responded. This integration of design, production, logistics, and doctrine became a template for post-war American military aviation. When the Navy began developing jet-powered carrier aircraft in the late 1940s, Grumman's philosophy survivability through redundancy, lethality through versatility, sustainability through maintainability infused every program. The A-6 Intruder, which entered service in 1963 and served through Desert Storm, embodied Avenger principles translated to the jet age: armored cockpit, redundant flight controls, multi-role payload flexibility, ease of maintenance. Naval Air Systems Command Historical Report, I-6 Program Development, 1961. The F-1 for Tomcat, Grumman's last manned fighter, featured dual engines, redundant hydraulic systems, and variable geometry wings that prioritized mission adaptability over single-point optimization. Even the Air Force, studying Navy carrier aviation's success rates during Korea and Vietnam, began incorporating redundancy and survivability features into tactical aircraft designs that earlier doctrine had dismissed as excessive weight. The Avenger's lesson that complex systems properly integrated produce simpler operational outcomes became axiomatic in American aerospace engineering. Air Force Systems Command Design Philosophy Review, 1972. The legacy extended beyond hardware into operational art. The concept of network-centric warfare, formalized during the 1990s around GPS guidance and data link communication, had conceptual roots in the Avenger's multi-role flexibility and coordinated strike tactics. During Desert Storm, coalition aircraft demonstrated Avenger-like versatility. FA-18 Hornets switching mid-mission from air superiority to ground attack, strike packages reconfiguring based on real-time intelligence, maintenance crews sustaining sortie rates that exhausted Iraqi defenders through sheer tempo. The cumulative psychological effect: an enemy facing relentless, adaptable pressure with no respite for reconstitution, mirrored the experience of Japanese commanders in 1944. Modern doctrinal manuals studying Desert Storm explicitly cite Pacific War carrier aviation as precedent, noting that technological sophistication matters less than systemic integration and sustainable operational tempo. Joint Publication 3-0, Joint Operations, 2017 edition. Historical Case Studies Annex. Yet the Avenger's ultimate impact was human. Of the approximately 10,000 naval aviators who flew Avengers in combat, over 8,200 survived the war, a survival rate exceeding 80%. Unprecedented for torpedo bomber crews. U.S. Navy Bureau of Personnel Casualty Records, 1941-45. These men returned to civilian life, carrying knowledge that complexity, properly managed, protects rather than that systems designed for survival enable aggression rather than constraining it. That engineering philosophy matters as much as engineering specifications. Many entered post-war aerospace and defense industries, carrying Grumman's lessons into the Cold War programs that would define American military aviation for 50 years. Others became educators, businessmen, public servants, but they carried with them an experiential understanding that institutional excellence requires integration, redundancy, and the humility to prioritize survival over elegance. The final accounting remained stark. Against an enemy that began the war with superior training, combat experience, and tactical doctrine, the Avenger, through design decisions made in a Long Island factory by engineers who never saw combat, achieved what firepower alone could not. It outlasted the opponent's ability to adapt. Japanese naval aviation, once the world's most proficient carrier striking force, collapsed not in a single apocalyptic defeat, but through cumulative attrition, inflicted mission after mission by an aircraft that refused to conform to pre-war assumptions about acceptable losses. The designer's overcomplication had been vindication of a different philosophy, that modern war rewards not the fastest or the most elegant, but the most persistent, the most adaptable, the most willing to return tomorrow and the day after, and the day after that, until the enemy has nothing left to resist with. In a photograph taken aboard USS Lexington in August 1945, days after the Japanese surrender, a Avenger crew poses before their aircraft. The turret is scorched. The fuselage bears patches over dozens of repaired holes. The nose art reads 53 and home 53 combat missions flown, 53 times returned. The pilot, a 23-year-old lieutenant from Kansas,